Hi, welcome to the bench. So today we have a mail. It's actually another tool that I picked up to do a little bit of work on a laptop. And I don't have one of these, which is kind of neat. It's a SMD rework station, essentially a hot air gun, or a hot air soldering station. And I figured I'd open it up. I bought this one off Amazon for I think $60-something if I remember correctly, something in the ballpark of that. And it's one of these. Hello. First of all, it's 110 volt, and it's one of these ones with the integrated fan and heating element in the handpiece. So, but helpful little buggers. Hot and do not poke anywhere. Sensitive. This is supposed to be ESD safe, so we're gonna go and we're gonna take it apart, since I don't trust dubious instruments of dubious quality very much. Look at that in a second. There we go. This is what I want to do. And this. Don't need that. Oops. Stuck it everywhere. All right, there we go. So it's actually a lot smaller than I anticipated this being. There we go. So it's got some buttons, and it's got this nice matte finish. Actually, I kind of like that. That's kind of nice. A couple of screws there for the holder. A dial for the airspeed, and that's actually kind of nice. On/off switch. Fuse. This equipment. So the model number is the R700. This is from Sigma. I have no idea who the heck Sigma is, and I am really guessing that these guys are a rebadge. It's got a bit of heft, so I imagine there's probably a transformer in there. Calibration, digital readout, temperature readout. No idea what the feedback loop is. There's supposed to be some sort of temperature monitoring here, but why don't we go? Yeah, let's start with the pointy bit, and we'll go take a look at this. All right, so there's just a couple of Phillips head screws in there, so we'll go ahead and pop these out. There's a certain saying in amongst the EEV blog forum of "Don't turn it on, take it apart." But with products of low quality levels, traditionally low quality levels from a certain country, which shall remain nameless, because that country probably changes over time, it's always the best bet to take it apart and just see how bad you're going to get screwed. I did another video on a floodlight that I got, and as expected, one of the floodlights was not connected anywhere, so super safe. Mains powered, no ground connected. Excellent. Good stuff. Alright. These are self-tappers into probably pretty shitty quality. Well, actually, glass is actually pretty good. This is a tough plastic. Let's see. How does this open? Oh, right. Forgot about this. Unscrew the front bit. And then this probably just lifts right out exactly. Look at that. Well, okay, so first and foremost, this thing is connected to what looks like a ground wire. Let's quick continuity check here. Let's see. Oh. Looks good. So the sheath here is definitely grounded, and it's not broken anywhere, so that's good news for what's inside too. Actually, let's do another quick check here. Okay, so the case is grounded too. Already a really good start. So what do we got here? We have the heating element. Oh yes, I remember seeing this. Okay. Yeah, so we have the heating element in there. Whoops. Yeah, great camera work. Let's see. I'm going to take a quick see that in there. Hopefully the light's not blowing out too much. That's better. So it's not too bad. ceramic heating element. Looks a little chowdery. Bet you this is going to smoke a little bit when I turn it on the first time. I don't know. I guess that gets held in like that. I don't know if there's a... Oh yeah, hey, look at that. Oh yeah, okay, it looks like there's... Yeah, okay, there's a couple of pins. So there's a couple of pins right here. I don't know if you can see right there. And there's another one on the other side too. Right there, and they go into little holes on the top and the bottom so that it actually kind of locks in place. The fan just fell out, that's okay. The other complaint I'd see... Oh, hello. Huh, that's cute. So it looks like they just melted the plastic around. Now let's get in here. You can see it looks like they melted the plastic around this nozzle so that it would fit around. Oh, that's just rubber. Okay, that's not so bad. Okay, so this is a rubber gasket kind of thing, and this is plastic. So it's sort of been molded, or sort of had itself molded around there. So that's kind of cool. So we've got the board here, which I guess is just not really much to do. So there's a sensor ground, there's a handle. Oh, that must be the sensor for the handle. Oh, the temperature sensor. There's a handle sensor. I don't know. There's some sort of magnetic sensor detection thingy in here. Let's go pull this whole board out and see what's going on behind it. Probably like a Hall effect sensor or something like that. Something to detect. You put it. I think the holder and other things are in here. I probably should open this box too. Oh, hey, look. So you get another heating element, which is nice. 3 nozzles of various sizes. Nice small one, fairly larger one, and you get the actual grippy thingy. And in here, there's a magnet. I don't know if I've got it. You can see, dunk. So that's going to activate some sort of Hall effect sensor. I'm going to do the rest of this. Or maybe not, maybe there's like a little reed switch or something like that. Probably be cheaper to have a reed switch now that I think about it. So let's see what we got here. We got another screw. God, I'm always screwed. Alright. And that's interesting. Maybe the reed sensor is actually in here. I guess that would make sense. It's like this. Huh. Yeah, I guess if it goes in like that, maybe it goes like that. Oh yeah, okay, so that makes sense. Although you would think that they would have put this on the other side if it went in like that. But anyway, okay. Either way, yeah, so I guess technically speaking, this goes in like this. The reed sensor probably would be up here. And that's probably it right there. Okay, so nothing on the circuit board. It's just there to, you know, do its thing. Kind of fun. So I'm going to put this all back and we'll jump into here. Before I put this back really quickly, I just wanted to point out that there was the motor that's used here. It's a YHFS 24 volt 0.15 amp DC motor. Clearly not brushless, but it doesn't matter. But the interesting thing is it's sort of molded. Well, it's got this rubber piece sort of attached to it, so you know, ostensibly you could replace this, which is probably a good thing considering I have no idea how good or bad this thing actually is. But it's always good that you can probably replace stuff. Never know when you're going to do something silly and need to fix things. Also, it's another thing worth noting that the input grill is a little small. There's style on the other side, but this side there's actually, so when you're holding it, you gotta be careful not to hold it like this with it blocked. So it's probably just, you'll probably be better off just holding like this anyway. So I'm gonna go finish this up and we'll be right back. Alright, let's get right into this guy now. I guess we'll just take, the two ends come off, so we'll try that first. So this is what looks like, because I have not turned it on, so I don't know what the behavior is on self-tappers again. Probably part of the course. So this is supposed to be a clone or a knockoff or a rebrand of the WEP 858, I think it is, 858D or something like that, and which has numerous clones and knockoffs and other brand names and whatever. So it's pretty much a fairly highly prized device for cloning. But this looks a little bit better and more solid than some of the other ones that I've seen. Oh, hello. Actually, let's just do a quick check here, because. And see, does it come with a fuse? Oh, it does. Look at that. What's this fuse? This is a 250 volt 6 amp fuse. And this is rated at 110 volt at 650 watts. So that's okay. That's reasonable. At least it makes sense. Before I lose it, because that would definitely be something I would do. Ruin my day real well. Okay. Oh yeah, look at that little transformer in there. Okay, let's get the front off. It's got some bulk to it, not a huge amount. I'm sure this can't be that interesting to watch me unscrew screws. One interesting thing about this one, they all have knobs here. This knob actually feels quite nice. Not that makes any difference whatsoever, because the debouncing of the buttons might be crap and the cal might be all over the place. But I've never heard of this company called Sigma, so who knows? It must be another Chinese brand. But in Canada here, perhaps we have different knockoff or rebrands than you do, or other people do in other places of the world. Okay, so here we go. Alright, so we're this way into the main circuit board here. Let me take a look at this right away, and what do we got here? We have okay, so there's a chip on here, actually. Okay, so essentially in here, there's only a transformer. So it's just a transformer in there. And it's a model YFEI48X24. Power transformer, input 110 volts at 60 hertz, red, output is 10 volt, blue, 30 volt, yellow. So it's a 10 and 30 volt. Very interesting. So it must be using both those power levels, and actually it makes sense. I guess the 30 volt is going to be used for the fan, and the 10, or maybe also the heating element, and I guess the 10 volts are used here. So what do we got here? Power switch, and that looks to be, that actually might be a real honkin' honest to goodness power switch. Yeah, that's a power switch that's connecting. Yep. So the power switch goes in here and switches the mains directly. I think it's the look and see. It looks like it's switching the neutral. So the hot goes through the fuse, and it comes on the board here. It goes to the transformer. No, okay. So wait a second. No, it's not. Aha. Nope. So so when this thing is powered up, the mains are fused, but they are not physically disconnected. So this transformer, when you plug it in, is energized. and then when you turn on this, it turns on the electronics. So not so great, but not the end of the world. You potentially could try and fix that by getting a double pull, double throw, where you'd actually disconnect the mains as well as the actual DC in, but whatever, doesn't matter. What do we have for flying here? We have a TP122 flying in the wind there. That should be. We have hot slot. Right, so that main chip, which after all of this, I was trying to get. That main chip is a S3F94CEEZZ-DK94. I have absolutely no clue what that is, but apparently they saw fit to put it in a socket, which is interesting. The pot is, probably run-of-the-mill El Cheapo pot. There's an LED display, an LED 7-segment display. It's 3 digits with some dots. The panel looks actually fairly nice. A couple of push buttons and a small. That's funny. So you can see it right there. Should use the pointer for this. You can see right here. There's a 3-legged surface, well, it's through hole, but board mount pot, which probably should have been mounted on the board and not just flying in the wind, but that's okay. And that's that. There's an what looks like an opto isolator there, or something of that nature. Fairchild. Get there. An LM385 op amp. And this is an Atmel. Hold on to your pants. An Atmel 42924CO2B. So I don't know what that is, but perhaps that's some sort of micro. And then the grounding wire here is absolutely ridiculously, shockingly small. And then you have the mains, or the power in here. Actually, wait a second. I think I'm talking out of my ass, which happens a lot. As it could be. Jeez. Pain in the ass to get at this. But, indeed. Oh, yeah. Oh, haha, cool. No, never mind. I talked out of my ass. This is a real mains power switch, so it's not just switching off the DC, the secondary side, and it's actually interrupting the primary side. Cool. Right on. Fun stuff. So yeah, it looks actually kind of okay. I wouldn't that actually having the mains switched off, physically switched off when you when you turn the unit off is actually quite, I say nice. It's not a feature that should be just by default. That's what you do. But all right, so there we go. Back again, and I've plugged everything up. I've got the Hot-air Rework station plugged into a kilowatt, and right now we're reading the current. We can switch it to watts. You can see that I have a very nominal 117.4 volts. I guess normal for here. And what we're gonna do is try not to set anything on fire, and we'll do the first pass. Now I have not read the instruction manual, as is typical of most males, so we'll just go ahead and turn it on. So it's using 30 milliwatts when the device is in the cradle. If I lift it out, well, there we go. Well, that's heating up quite fast. Oh, there's a delightful smell. It's probably, hopefully it's nothing burning. Yeah, it's pretty hot, although I don't really believe that's 300 degrees, although maybe it's 300 Fahrenheit. So I'm going to turn this up. Oh yeah. Oh, you know what? That's actually nice. So you get the set point first of all. Let's see how far down this is going to go. 100. Of course, we can blow cold air through it, and if we don't blow anything, it is slowing down, so that's good. So that means it's probably taking a real measurement at least. Pardon me. So it's not actually showing the temperature it's at until you pull it open. Or pull it open when you lift it up. That's interesting. And there's no, of course this is not a good thing. So it seems to leave the fan on ever so slightly. But it stays nice and hot. So we're using 0.03 of an amp. We lift it up. We go, it's pulsing it. So we're pulsing about 2.5, 1.7, 1 amps. It's not bad. It's probably not running the heating element either. Let me go get a board and we'll play around with it. Alright, we have our first victim. And our first victim is one of these cheap ass, shitty wireless B fucking notebook adapters. PCMCA. God damn, but did I hate these. Anyway, so we're going to take it apart. We're going to take it apart in a fairly brutal fashion. As such, I doubt this thing will ever work ever again. But that doesn't bother me very much, because quite frankly I hate this piece of crap. So, I'll burn up my mat. So we'll go ahead and we'll put this inside of a little set of helping hands, and we'll target this RTL chip, this 8180L. Oh yes, I remember this POS. Well, there's also a nice little crystal there, 44 megahertz crystal. Pop that off. That might be handy to hang on to. So, bring this up. We'll bring this up to, say, 300 miscellaneous units. Well, I should probably calibrate this too. So here. I'm going to grab a meter. And grab a cheap and cheerful thermocouple, which I'm not entirely sure this one works, but we'll see. In degrees Celsius. So we're reading ambient inside the case 21 degrees, ambient outside the case 20 point something and change. Looks good. So we'll measure the tip temperature. Tip temperature is 22 degrees. So we'll put this on 2. And I'll put this about a centimeter. Actually, I'm going to try and get this in frame. There we go. Put this, about, say, a centimeter away. Actually, straight up. How about I try not to, wreck my... There you go, okay. So it's measuring at the tip about 283. Okay, so it's fluctuated anywhere between 315, 314. So about a centimeter and change away from the tip, the nozzle, sorry. We're at about 320 something. So that probably would go down a little bit. It'd be really nice if they indicated what was up and what was down. So I guess my only option right now is to finger poke this, actually. Yeah, okay. Let's see. I'm gonna try and get in there. Oh yeah, alright, well that works. Alright, so. Should maybe. Ooh, that was stupid of me, huh? Silliness on camera. Yeah, I didn't need that fingerprint anyway, huh? On my. There we go. I was gonna say do something stupid, but okay. Didn't end up doing something stupid there. Alright. So. So with it set now, measuring it's a bit high, so let's assume we'll assume turning it left was turning it down. Oh, if that's the case, that was really sensitive. Alrighty. That's still a bit low. And it seems to freak out when you turn the calibration around. It's pretty high now. Suffice to say that this thing is bloody sensitive on the calibration, which is kind of, too bad. Oh, hello. Yeah, geez, 10 degrees off. I'd buy that for $1. Now let's assume I can pull it out without wrecking the calibration. Put that in there. Okay, so with our dubiously calibrated meter and our crappy, cheap, and cheerful thermocouple, we're getting approximately within 10 degrees. So that's good. I'm okay with that for the moment. Now this is cute, so it actually tells you it's coming down. It must come down to about 120, 100 something degrees before going into sleep mode. So let's go. get this component off. I need some tweezers though. Okay, let's go get one of these smaller ones off. Let me bring up the airflow a bit. Now granted, that was with an airflow of 2, so maybe it'll have a harder time with a lower airflow. I'm not sure. A higher airflow, pardon me. Oh yeah, it came right off. That's nice. Okay. That was easy enough. Alright, let's try and get this big guy up. Now normally you'd have a sort of a quad flat pack style attachment. You'd also have a set of tweezers that was, you know, reasonable for doing this kind of thing. Not bad. The pins are mostly unmangled, and that's mostly because I'm not going to blame the tool for that, because that's mostly because of me not having the right tool for actually pulling the chip off. I'm using a pair of crappy tweezers for that. Alright, well, let's see how far else we can get. Oh, let's get this crystal out. Should totally be able to do that. So far this is pretty good. I haven't used a lot of hot air reflow, but the one at work is you know, okay. Oh, there we go. That'll come right off. Now maybe this is set too high. So what we'll do is we'll grab our meter again. We'll put it on the board and see what sort of temperatures we're getting on the actual board. You see that? Yeah, you can see that. Okay. Okay, so at about 1.5 centimeters high speed, we're getting maybe about 240 degrees Celsius. It's not too bad. So we'll really start blowing this sucker. I see, this is the problem when you're doing reflow. Okay, so that's... So, of course, this is the issue, right? So, if you choose a... Whoops, that's not a smart idea. Okay. If you choose a high flow rate, I mean, things just start flying off of your board like this inductor and this... What the hell this is? Cap, maybe? Diode? Probably a diode. This one popped off here, and I'm sure other things have popped off too. So, you know, gotta watch out. So cool. Actually, you know, my first impressions of this are actually rather pleasantly surprised. I thought I was going to get a fairly crap unit. I mean, I knowingly, should say, I knowingly bought this saying, well, you know, it's $60, and I don't do a lot of hot air rework. I typically try and use the soldering iron whenever possible, you know, using two if you need to, just whipping chips off or whatnot. So I don't typically use a hot air station. And recently there's been a couple of projects where I kind of really needed this, or something like this. So I think it'll be a great addition for those few times that I need to, just do a small job here or there. And it definitely seems to work reasonably, well enough. You can get replacement hand pieces for this. It will involve going in here and probably undoing this and whatnot, but in all honesty, if that starts happening, maybe I'll looking at getting a connector if I use it enough to really warrant it, and these break enough to get a replacement. I'll look at getting a connector, whatever, and then just Frankensteining in a connector on the end of this, whatever replacement I get, so I don't have to keep on going into the unit. But yeah, I can't find any major faults with it. It does what it's supposed to do. Came with a handful of nozzles, and these are apparently fairly universal. So, you can buy ones with a quad flat pack design, so you can just come right over the chip, with the iron, and just whack it right over there, and it'll heat just the just the edges of the chip, which is what you want to do. And just again, it comes with a 2mm, I think. Is it 2mm? Yeah. Complete non-product placement. No, this is a 5mm. This is probably an 8 or something like that. Oh, near enough, I can't tell. 7 or 8. And this one is a honkin' 10mm. So it's supposed to come with a 2mm, but oh well, whatever. 5, 7, and 10mm are just fine for me. So that's that, and you said you get the replacement heating element, or a spare heating element, which, kind of cool, but I suspect it'll probably be the fan that'll go before the heating element, unless the heating element is complete crap, which, that's possible. So like I said, this is the Sigma R700, pardon me. I bought it off Amazon. I'll, play around with it a bit, and if it's worthwhile, I'll link to it. But you can look on it. I got it on Amazon.ca. They offer next day shipping, which I didn't take, but we'll say that that would work. The packaging was fine. Typical Amazon crushed paper in a big box. Nothing majorly bad with that. The buttons here are not a pain in the butt to use. I mean, if I was constantly moving the temperature up and down and up and down, that would get really tiring really quickly. But I mean, the acceleration on the input is really good. It starts speeding up pretty well. It seems to land on a certain temperature, so like 100, 300, or whatever. I'm not sure if that's by design or if that's just because I'm really darn lucky. I suspect it's probably the firmware, which is not a big deal. I have no problems with that. Like I said, the button's kind of nice. There's a little bit of resistance there, so it's not like a really floopy, loosey-goosey, my contacts are about to break feeling. That being said, who knows how long this is going to survive for. The button itself is a little weird. I've never seen anybody use a button like this before, but who cares, right? Like, I don't really give a crap. It's not at all important. Little details like the LED, not the LED, but the 7-segment red bezel is nice and flush, or fairly flush, as much as flush as I would expect with the front panel. The look and feels nice. Like I said, the matte black finish is fantastic. I actually quite like that, much better than sort of the anodized aluminum. So it's got a nice feel to it. The plastic's, a good, reasonable quality plastic. Easy to get into. Yeah, the self-tappers are crap, so you have to pull this apart a few times and that'll be the end of that, but no big deal. So like I said, and the power switch is good. Main's disconnected. That's kind of important. A friend of mine on the EV blog said that he had one of these and it did not disconnect the mains, and it basically melted down and shorted out on his bench, which is terrifying. One reason why I shut all the power to my bench off, but again, it's really nice that when you kill the power switch there, that this is disconnected and that's it. There's nothing going through there. You can't short out a coil in the transformer or anything, so that's nice. So all in all, I'd give it, on my crappy opinion, useless, crappy, worthless opinion, I'd say that's easily a 7 on 10, given that it's a $60 tool. which, you know, we're not talking $1,000 tool. So in the class of something you'd buy for a home lab for occasional use. I'll have to actually do a few more repairs, but my preliminary assessment is, you know, easily a 6 and a 6 or 7, and definitely the construction quality is very acceptable. Out of the box, everything's grounded well. I didn't check actually the grounding mount for the on the inside, but you know, I'll assume it's reasonably okay. The cord looked fine. There's nothing electrically that looked dodgy about it. It looked like it was in reasonably good. It had been assembled reasonably well. So that's that. Thanks for watching. Hope you found it useful, and get out there and build some. Catch you later. Cheers.